cave. She struggled upward, and her head broke the surface, but she saw only water, great swells rising 15 feet above her on all sides. The power of the ocean was immense. The surge dragged her forward, then back, and she was helpless to resist. She could not see the boat anywhere, only foaming sea on all sides. She could not see the island, only water. Only water. She fought a sense of overwhelming panic. She tried to kick against the current, but her boots were leaden. She sank down again and struggled back, gasping for air. She had to get her boots off somehow. She gulped a breath and ducked her head under the water and tried to unlace the boots. Her lungs burned as she fumbled with the knots. The ocean swept her back and forth, ceaselessly. She got one boot off, gulped air, and ducked down again. Her fingers were stiff with cold and fright as she worked on the other boot. It seemed to take hours. Finally, her legs were free, light, and she dog-paddled, catching her breath. The surge lifted her high, dropped her again. She could not see the island. She felt panic again. She turned and felt the surge lift once more, and then she saw the island. The sheer cliffs were close, frighteningly close. The waves boomed as they smashed against the rocks. She was no more than 50 yards offshore, being swept inexorably toward the crashing surf. On the next crest, she saw the cave, 100 yards to her right. She tried to swim toward it, but it was hopeless. She had no power at all to move in this gigantic surf. She felt only the strength of the sea sweeping her to the cliffs. Panic made her heart race. She knew she would be instantly killed. A wave crested over her. She gulped seawater and coughed. Her eyes blurred. She felt nausea and deep, deep terror. She put her head down and began to swim, arm over arm, kicking as hard as she could. She had no sense of movement, only the sideways pull of the surge. She dared not look up. She kicked harder. When she raised her head for another breath, she saw she had moved a little, not much, but a little, to the north. She was a little nearer to the cave. She was encouraged, but she was terrified. She had so little strength. Her arms and legs ached with her effort. Her lungs burned. Her breath came in short, ragged, heaving gasps. She coughed again, grabbed another breath, put her head down, and kicked onward. Even with her head in the water, she heard the deep boom of the surf against the cliffs. She kicked with all her might. The currents and surge moved her left and right, forward and back. It was hopeless, but still she tried. Gradually, the ache in her muscles became a steady, dull pain. She felt she had lived with this pain all her life. She did not notice it any more. She kicked on, oblivious. When she felt the surge lift her up again, she raised her head for a breath. She was startled to see that the cave was very close. A few more strokes and she would be swept inside it. She had thought the current might be less severe around the cave, but it wasn't. On either side of the opening, the waves crashed high, climbing the cliff walls and then falling back. The boat was nowhere in sight. She ducked her head down again, kicked forward, using the last of her strength. She could feel her entire body weakening. She couldn't last much longer. She knew she was being carried toward the cliffs. She heard the boom of the surf, louder now, and she kicked again, and suddenly a huge swell swept her up, lifting her, carrying her toward the cliffs. She was powerless to resist it. She raised her head to look, and saw darkness, inky darkness. In her exhaustion and pain, she realized that she was inside the cave. She had been swept into the cave. The booming sound was hollow, reverberating. It was too dark to see the walls on either side. The current was intense, sweeping her ever deeper. She gasped for breath and paddled ineffectually. Her body scraped against rock. She felt a moment of searing pain, and then she was swept farther into the depths of the cave. But now there was a difference. She saw faint light on the ceiling, and the water around her seemed to glow. The surge lessened. She found it easier to keep her head above water. She saw hot light ahead, brilliantly hot, the end of the cave. And suddenly, astonishingly, she was carried through and burst into sunlight and open air. She found herself in the middle of a broad, muddy river surrounded by dense green foliage. The air was hot and still. She heard the distant cries of jungle birds. Up ahead, around a bend in the river, she saw the stern of Dodgson's boat, already tied up to the shore. She could not see any of the people, and she didn't want to see them. Summoning her remaining strength, she kicked toward shore and clutched at a stand of mangroves growing thickly along the water's edge. Too weak to hold on, she hooked her arm around a root and lay on her back in the gentle current, looking up at the sky, gasping for breath. She did not know how much time passed, but finally she felt strong enough to haul herself arm over arm along the mangrove roots at the water's edge until she came to a narrow break in the foliage leading to a patch of muddy shore beyond. As she dragged herself out of the water and up on the slippery bank, she noticed several rather large animal footprints in the mud. They were curious, three-toed footprints, with each toe ending in a large claw. She bent to examine them more closely, and then she felt the earth vibrating, trembling beneath her hands. A large shadow fell over her, and she looked up in astonishment at the leathery, pale underbelly of an enormous animal. She was too weak to react, even to raise her head. The last thing she saw was a huge, leathery foot landing beside her, squishing in the mud, and a soft, snorting sound. And then, suddenly, abruptly, exhaustion overtook her, and Sarah Harding collapsed and fell onto her back. Her eyes rolled up into her head, and she lost consciousness. Dodgson. A few yards up from the shore of the river, Louis Dodgson climbed into the custom-made Jeep Wrangler and slammed the door shut. Beside him in the passenger seat, Howard King was wringing his hands. He said, "How could you have done that to her?" "Done what?" George Basilton said from the back seat. Dodgson did not reply. He turned the key in the ignition. The engine rumbled to life. He popped the four-wheel drive into gear and headed up the hill into the jungle, away from the boat at the shore. "How could you?" King said again, agitated. "I mean, Jesus!" "What happened was an accident," Dodgson said. "An accident? An accident?" "That's right, an accident," Dodgson said calmly. "She fell overboard." "I didn't see anything," Basilton said. King was shaking his head. "Jesus, what if somebody comes to investigate and—" "What if they do?" Dodgson said, interrupting him. "We were in rough seas. She was standing at the bow. A big wave hit us, and she was washed overboard. She couldn't swim very well. We circled and looked for her, but there was no hope. A very unfortunate accident." "So what are you concerned about?" "What am I concerned about?" "Yes, Howard, exactly. What the fuck are you concerned about?" "I saw it, for Christ's sake." "No, you didn't," Dodgson said. "I didn't see anything," Basilton said. "I was down below the whole time." "That's fine for you," Howard King said. "But what if there's an investigation?" The jeep bounced up the dirt track, moving deeper into the jungle. "There won't be," Dodgson said. "She left Africa in a hurry, and she didn't tell anybody where she was going." "How do you know?" King whined. "Because she told me, Howard. That's how I know. Now get the map out and stop moaning. You knew the deal when you joined me." "I didn't know you were going to kill somebody, for Christ's sake." "Howard," Dodgson said with a sigh, "nothing's going to happen. Get the map out." "How do you know?" King said. "Because I know what I'm doing," Dodgson said. "That's why. Unlike Malcolm and Thorne, who are somewhere on this island, screwing around, doing fuck knows what in this damn jungle." Mention of the others caused a new worry. Fretting, King said, "Maybe we'll run into them." "No, Howard, we won't. They'll never even know we're here. We're only going to be on this island for 4 hours, remember? Land at 1, back on the boat by 5, back at the port by 7, back in San Francisco by midnight. Bang, done, finito, and finally, after all these years, I'll have what I should have had long ago." "Dinosaur embryos," Basilton said. "Embryos?" King asked, surprised. "Oh, I'm not interested in embryos anymore," Dodgson said. "Years ago I tried to get frozen embryos, but there's no reason to bother with embryos now. I want fertilized eggs. And in 4 hours I'll have them from every species on this island." "How can you do that in 4 hours?" "Because I already know the precise location of every dinosaur breeding site on the island. The map, Howard." King opened the map. It was a large topographical chart of the island, 2 feet by 3 feet, showing terrain elevations in blue contours. At several places in lowland valleys there were dense red concentric circles. In some places, clusters of circles. "What's this?" King said. "Why don't you read what it says?" Dodgson said. King turned the map and looked at the legend. "Sigma Data Landsat Nordstat Mixed Spectra," and then a bunch of numbers. "No, wait, dates." "Correct," Dodgson said. "Dates." "Past dates? This is a summary chart combining data from several satellite passes?" "Correct." King frowned. "And it looks like visible spectrum and false aperture radar and what?" "Infrared, broadband thermal VR." Dodgson smiled. "I did all this in about 2 hours. Downloaded all the satellite data, summarized it, and had the answers I wanted." "I get it," King said. "These red circles are infrared signatures." "Yes," Dodgson said. "Big animals leave big signatures. I got all the satellite flybys over this island for the last few years and mapped the location of heat sources. And the locations overlapped from pass to pass, which is what makes these red concentric marks, meaning that the animals tend to be located in these particular places." "Why?" He turned to King. "Because these are the nesting sites." "Yes, they must be," Basilton said. "Maybe that's where they eat," King said. Dodgson shook his head irritably. "Obviously those circles can't be feeding sites." "Why not?" "Because these animals average 20 tons apiece, that's why. You get a herd of 20-ton dinos, and you're talking a combined biomass of more than 500,000 pounds moving through the forest. That many big animals are going to eat a lot of plant matter in the course of a day. And the only way they can do that is by moving, right?" "I guess." "You guess? Look around you, Howard. Do you see any denuded sections of forest? No, you don't. They eat a few leaves from the trees and move on. Trust me, these animals have to move to eat, but what they don't move is their nesting sites. So these red circles must be nesting sites." He glanced at the map. "And unless I'm wrong, the first of the nests is just over this rise and down the hill on the other side." The jeep fishtailed in a patch of mud and ground forward, lurching up the hill. Mating calls. Richard Levine stood in the high hide, staring at the herds through binoculars. Malcolm had gone back to the trailer with the others, leaving Levine alone. In fact, Levine was relieved to have him gone. Levine was quite content to make observations on these extraordinary animals, and he was aware that Malcolm did not share his boundless enthusiasm. Indeed, Malcolm always seemed to have other considerations on his mind. And Malcolm was notably impatient with the act of observation. He wanted to analyze the data, but he did not want to collect it. Of course, among scientists, that represented a well-known difference in personality. Physics was a perfect example. The experimentalists and the theorists lived in utterly different worlds, passing papers back and forth, but sharing little else in common. It was almost as if they were in different disciplines. And for Levine and Malcolm, the difference in their approach had surfaced early, back in the Santa Fe days. Both men were interested in extinction, but Malcolm approached the subject broadly from a purely mathematical standpoint. His detachment, his inexorable formulas, had fascinated Levine, and the two men began an informal exchange over frequent lunches. Levine taught Malcolm paleontology. Malcolm taught Levine nonlinear mathematics. They began to draw some tentative conclusions which both found exciting, but they also began to disagree. More than once they were asked to leave the restaurant. Then they would go out into the heat of Guadalupe Street and walk back toward the river, still shouting at each other, while approaching tourists hurried to the other side of the street. In the end, their differences came down to personalities. Malcolm considered Levine pedantic and fussy, preoccupied with petty details. Levine never saw the big picture. He never looked at the consequences of his actions. For his own part, Levine did not hesitate to call Malcolm imperious and detached, indifferent to details. "God is in the details," Levine once reminded him. "Maybe you're God," Malcolm shot back. "Not mine. Mine is in the process." Standing in the high hide, Levine thought that answer was exactly what you would expect from a mathematician. Levine was quite satisfied that details were everything, at least in biology, and that the most common failing of his biological colleagues was insufficient attention to detail. For himself, Levine lived for the details, and he could not ever let them go. Like the animal that had attacked him with Diego, Levine thought of it often, turning it over and over again, reliving the events. Because there was something troubling, some impression that he could not get right. The animal had attacked quickly, and he had sensed it was a basic theropod form, hind legs, stiff tail, large skull, the usual. But in the brief flash in which he had seen the creature, there seemed to be a peculiarity around the orbits, which made him think of Carnotaurus sastrii, from the Goro Frigo formation in Argentina, and in addition, the skin was extremely unusual. It seemed to be a sort of bright mottled green. But there was something about it. He shrugged. The troubling idea hung in the back of his mind, but he couldn't get to it. He just couldn't get it. Reluctantly, Levine turned his attention to the parasaur herd, browsing by the river alongside the apatosaurs. He listened as the parasaurs made their distinctive, low, trumpeting sounds. Levine noticed that most often the parasaurs made a sound of short duration, a kind of rumbling honk. Sometimes several animals made this sound at once, or very nearly overlapping, so it seemed to be an audible way of indicating to the herd where all the members were. Then there was a much longer, more dramatic trumpeting call. This sound was made infrequently, and only by the two largest animals in the herd, which raised their heads and trumpeted loud and long. But what did the sound mean? Standing there in the hot sun, Levine decided to perform a little experiment. He cupped his hands around his mouth and imitated the parasaur's trumpeting cry. It wasn't a very good imitation, but immediately the lead parasaur looked up, turning its head this way and that, and it gave a low cry answering Levine. Levine gave a second call. Again the parasaur answered. Levine was pleased by this response and made an entry in his notebook. But when he looked up again, he was surprised to see that the parasaur herd was drifting away from the apatosaurs. They collected together, formed a single line, and began to walk directly toward the high hide. Levine started to sweat. What had he done? In some bizarre corner of his mind, he wondered if he had imitated a mating cry. That was all he needed, to attract a randy dinosaur. Who knew how these animals behaved in mating? With growing anxiety, he watched them march forward. Probably he should call Malcolm and ask his advice. But as he thought about it, he realized that by imitating that cry, he had interfered with the environment, introduced a new variable. He had done exactly what he had told Thorne he did not intend to do. It was thoughtless, of course, and surely not very important in the scheme of things. But Malcolm was certain to give him hell about it. Levine lowered his binoculars and stared. A deep trumpeting sound reverberated through the air, so loud it hurt his ears. The ground began to shake, making the high hide sway back and forth precariously. My God, he thought, they're coming right for me. He bent over, and with fumbling fingers, searched his backpack for the radio. Problems of evolution. In the trailer, Thorne took the rehydrated meals out of the microwave and passed the plates around the little table. Everyone unwrapped them and began to eat. Malcolm poked his fork into the food. "What is this stuff?" "Herb-baked chicken breast," Thorne said. Malcolm took a bite and shook his head. "Isn't technology wonderful?" he said. "They managed to make it taste just like cardboard." Malcolm looked at the two kids seated opposite him, who were eating energetically. Kelly glanced up at him and gestured with her fork at the book strapped into a shelf beside the table. "One thing I don't understand." "Only one?" Malcolm said. "All this business about evolution," she said. "Darwin wrote his book a long time ago, right?" "Darwin published The Origin of Species in 1859, Malcolm said. "And by now everybody believes it, isn't that right?" "I think it's fair to say that every scientist in the world agrees that evolution is a feature of life on Earth," Malcolm said, "and that we are descended from animal ancestors, yes." "Okay," Kelly said. "So what's the big deal now?" Malcolm smiled. "The big deal," he said, "is that everybody agrees evolution occurs, but nobody understands how it works. There are big problems with the theory, and more scientists are admitting it." Malcolm pushed his plate away. "You have to track the theory," he said, "over a couple of 100 years. Start with Baron Georges Cuvier, the most famous anatomist in the world in his day, living in the intellectual center of the world, Paris. Around 1800, people began digging up old bones, and Cuvier realized that they belonged to animals no longer found on Earth. That was a problem, because back in 1800 everybody believed that all the animal species ever created were still alive. The idea seemed reasonable because the Earth was thought to be only a few thousand years old, and because God, who had created all the animals, would never let any of his creations become extinct. So extinction was agreed to be impossible. Cuvier agonized over these dug-up bones, but he finally concluded that, God or no God, many animals had become extinct. As a result, he thought of worldwide catastrophes, like Noah's flood. "Okay." "So Cuvier reluctantly came to believe in extinction," Malcolm said, "but he never accepted evolution. In Cuvier's mind, evolution didn't occur. Some animals died and some survived, but none evolved. In his view, animals didn't change. Then along came Darwin, who said that animals did evolve and that the dug-up bones were actually the extinct predecessors of living animals. The implications of Darwin's idea upset lots of people. They didn't like to think of God's creations changing, and they didn't like to think of monkeys in their family trees. It was embarrassing and offensive. The debate was fierce, but Darwin amassed a tremendous amount of factual data. He had made an overwhelming case. So, gradually, his idea of evolution was accepted by scientists and by the world at large. But the question remained, how does evolution happen? For that, Darwin didn't have a good answer. "Natural selection," Arby said. Yes, that was Darwin's explanation. The environment exerts pressure which favors certain animals, and they breed more often in subsequent generations, and that's how evolution occurs. But as many people realized, natural selection isn't really an explanation, it's just a definition. If an animal succeeds, it must have been selected for. But what in the animal is favored? And how does natural selection actually operate? Darwin had no idea, and neither did anybody else for another 50 years. "But it's genes," Kelly said. "Okay," Malcolm said. "Fine. We come to the 20th century. Mendel's work with plants is rediscovered. Fisher and Wright do population studies. Pretty soon we know genes control heredity, whatever genes are. Remember, through the first half of the century, all during World War I and World War II, nobody had any idea what a gene was. After Watson and Crick in 1953, we knew that genes were nucleotides arranged in a double helix. Great. And we knew about mutation. So, by the late 20th century, we have a theory of natural selection which says that mutations arise spontaneously in genes, that the environment favors the mutations that are beneficial, and out of this selection process, evolution occurs. It's simple and straightforward. God is not at work, no higher organizing principle involved. In the end, evolution is just the result of a bunch of mutations that either survive or die, right? Right, Arby said. But there are problems with that idea, Malcolm said. First of all, there's a time problem. A single bacterium, the earliest form of life, has 2,000 enzymes. Scientists have estimated how long it would take to randomly assemble those enzymes from a primordial soup. Estimates run from 40 billion years to 100 billion years, but the Earth is only 4 billion years old. So chance alone seems too slow, particularly since we know bacteria actually appeared only 400 million years after the Earth began. Life appeared very fast, which is why some scientists have decided life on Earth must be of extraterrestrial origin, although I think that's just evading the issue. Okay. Second, there's the coordination problem. If you believe the current theory, then all the wonderful complexity of life is nothing but the accumulation of chance events, a bunch of genetic accidents strung together. Yet when we look closely at animals, it appears as if many elements must have evolved simultaneously. Take bats, which have echolocation. They navigate by sound. To do that, many things must evolve. Bats need a specialized apparatus to make sounds. They need specialized ears to hear echoes. They need specialized brains to interpret the sounds. And they need specialized bodies to dive and swoop and catch insects. If all these things don't evolve simultaneously, there's no advantage. And to imagine all these things happen purely by chance is like imagining that a tornado can hit a junkyard and assemble the parts into a working 747 airplane. It's very hard to believe. Okay, Thorne said. I agree. Next problem. Evolution doesn't always act like a blind force should. Certain environmental niches don't get filled, certain plants don't get eaten, and certain animals don't evolve much. Sharks haven't changed for 160 million years. Opossums haven't changed since dinosaurs became extinct 65 million years ago. The environments for these animals have changed dramatically, but the animals have remained almost the same. Not exactly the same, but almost. In other words, it appears they haven't responded to their environment. Maybe they're still well adapted, Arby said. Maybe, or maybe there's something else going on that we don't understand. Like what? Like other rules that influence the outcome. Thorne said. Are you saying evolution is directed? No, Malcolm said. That's creationism, and it's wrong, just plain wrong. But I am saying that natural selection acting on genes is probably not the whole story. It's too simple. Other forces are also at work. The hemoglobin molecule is a protein that is folded like a sandwich around a central iron atom that binds oxygen. Hemoglobin expands and contracts when it takes on and gives up oxygen like a tiny molecular lung. Now, we know the sequence of amino acids that make up hemoglobin, but we don't know how to fold it. Fortunately, we don't need to know that because if you make the molecule, it folds all by itself. It organizes itself. And it turns out, again and again, that living things seem to have a self-organizing quality. Proteins fold, enzymes interact, cells arrange themselves to form organs, and the organs arrange themselves to form a coherent individual. Individuals organize themselves to make a population, and populations organize themselves to make a coherent biosphere. From complexity theory, we're starting to have a sense of how this self-organization may happen and what it means, and it implies a major change in how we view evolution. But, Arby said, in the end, evolution still must be the result of the environment acting on genes. I don't think it's enough, Arb, Malcolm said. I think more is involved. I think there has to be more, even to explain how our own species arose. About 3 million years ago, Malcolm said, some African apes that had been living in trees came down to the ground. There was nothing special about these apes. Their brains were small and they weren't especially smart. They didn't have claws or sharp teeth for weapons. They weren't particularly strong or fast. They were certainly no match for a leopard. But because they were short, they started standing upright on their hind legs to see over the tall African grass. That's how it began, just some ordinary apes looking out over the grass. As time went on, the apes stood upright more and more of the time. That left their hands free to do things. Like all apes, they were tool users. Chimps, for example, used twigs to fish for termites, that sort of thing. As time went on, our ape ancestors developed more complex tools. That stimulated their brains to grow in size and complexity. It began a spiral. More complex tools provoked more complex brains, which provoked more complex tools. And our brains literally exploded in evolutionary terms. Our brains more than doubled in size in about 1 million years, and that caused problems for us. Like what? Like getting born, for one thing. Big brains can't pass through the birth canal, which means that both mother and child die in childbirth. That's no good. What's the evolutionary response? To make human infants born very early in development, when their brains are still small enough to pass through the pelvis. It's the marsupial solution. Most of the growth occurs outside the mother's body. A human child's brain doubles during the first year of life. That's a good solution to the problem of birth, but it creates other problems. It means that human children will be helpless long after birth. The infants of many mammals can walk minutes after they're born. Others walk in a few days or weeks. But human infants can't walk for a full year. They can't feed themselves for even longer. So one price of big brains was that our ancestors had to evolve new, stable social organizations to permit long-term child care, lasting many years. These big-brained, totally helpless children changed society. But that's not the most important consequence. No? No. Being born in an immature state means that human infants have unformed brains. They don't arrive with a lot of built-in instinctive behavior. Instinctively, a newborn infant can suck and grasp, but that's about all. Complex human behavior is not instinctive at all. So human societies had to develop education to train the brains of their children, to teach them how to act. Every human society expends tremendous time and energy teaching its children the right way to behave. You look at a simpler society in the rainforest somewhere, and you find that every child is born into a network of adults responsible for helping to raise the child. Not only parents, but aunts and uncles and grandparents and tribal elders. Some teach the child to hunt or gather food or weave. Some teach them about sex or war. But the responsibilities are clearly defined, and if a child does not have, say, a mother's brother's sister to do a specific teaching job, the people get together and appoint a substitute. Because raising children is, in a sense, the reason the society exists in the first place. It's the most important thing that happens, and it's the culmination of all the tools and language and social structure that has evolved. And eventually, a few million years later, we have kids using computers. Now, if this picture makes sense, where does natural selection act? Does it act on the body, enlarging the brain? Does it act on the developmental sequence, pushing the kids out early? Does it act on social behavior, provoking cooperation and child caring? Or does it act everywhere all at once, on bodies, on development, and on social behavior? Everywhere at once, Arby said. I think so, Malcolm said. But there may also be parts of this story that happen automatically, the result of self-organization. For example, infants of all species have a characteristic appearance. Big eyes, big heads, small faces, uncoordinated movements. That's true of kids and puppies and baby birds. And it seems to provoke adults of all species to act tenderly toward them. In a sense, you might say, infant appearance seems to self-organize adult behavior. And in our case, a good thing, too. Thorne said, "What does that have to do with dinosaur extinction?" Self-organizing principles can act for better or worse. Just as self-organization can coordinate change, it can also lead a population into decline and cause it to lose its edge. On this island, my hope is we'll see self-organizing adaptations in the behavior of real dinosaurs, and it'll tell us why they became extinct. In fact, I'm pretty sure we already know why the dinosaurs became extinct. The radio clicked. "Bravo!" Levine said over the intercom. "I couldn't have put it better myself, but perhaps you better see what is happening out here. The parasaurs are doing something very interesting, Ian." "What's that?" "Come and look." "Kids," Malcolm said, "you stay here and watch the monitors." He pressed the radio button. "Richard, we're on our way." Parasaurs. Richard Levine gripped the railing of the high hide and watched tensely. Directly ahead, coming into view over a low rise, he saw the magnificent head of a Parasaurolophus walkeri. The duck-billed hadrosaur's skull was 3 feet long, but it was made larger by a long, horned crest that extended backward high in the air. As the animal approached, Levine could see the green mottling on the head. He saw the long, powerful neck, the heavy body with its light green underbelly. The Parasaurolophus was 12 feet tall and roughly the size of a large elephant. Its head was almost as high as the floor of the high hide. The animal moved steadily toward him, its footsteps thumping on the ground. Moments later, he saw a second head appear over the rise, then a third and a fourth. The animals trumpeted and walked in single file directly toward him. Within moments, the lead animal was abreast of the hide. Levine held his breath as it passed. The animal stared at him, its large brown eye rolling to watch him. It licked its lips with a dark purple tongue. The hide shook with its footsteps, and then it passed, continuing on toward the jungle behind. Soon after, the second animal passed. The third animal brushed against the structure, rocking it slightly, but the dinosaur did not seem to notice. It continued steadily on. So did the others. One by one they disappeared into the dense foliage behind the high hide. The earth ceased to vibrate. It was then that he saw the game trail running past the high hide and into the jungle. Levine sighed. His body relaxed slowly. He picked up his binoculars and took a deep breath, calming himself. His panic faded. He began to feel better. And then he thought, what are they doing? Where are they going? Because, as he considered it, the behavior of the parasaurs seemed extremely strange. They had been in a defensive cluster while they fed, but in movement they had shifted to single file, which broke the usual clumped herd pattern and made every animal vulnerable to predation. Yet the behavior was clearly organized. Moving in single file must serve some purpose. But what? Now that they were within the jungle, the animals had begun making low trumpeting sounds of short duration. Again, he had the sense that this was some sort of vocalization to convey position. Perhaps for members to keep track of each other while they moved through the jungle, while they changed locations. But why were they changing locations? Where were they going? What were they doing? He certainly couldn't tell here, standing up in the high hide. He hesitated, listening to them. Then, in a decisive moment, he swung his leg over the railing and climbed quickly down the scaffolding. Heat. She felt heat and wet. Something rough scraped along her face like sandpaper. It happened again, this roughness on her cheek. Sarah Harding coughed. Something dripped on her neck. She smelled an odd, sweetish odor, like fermenting African beer. There was a deep, hissing sound, then the rough scraping again, starting at her neck, moving up her cheek. Slowly she opened her eyes and stared up into the face of a horse. The big, dull eye of the horse peered down at her with soft eyelashes. The horse was licking her with its tongue. It was almost pleasant, she thought, almost reassuring. Lying on her back in the mud, with a horse. It wasn't a horse. The head was too narrow. She suddenly saw the snout too tapered, the proportions all wrong. She turned to look and saw that it was a small head leading to a surprisingly thick neck and a heavy body. She jumped up, scrambling to her knees. "Oh, my God!" Her sudden movement startled the big animal, which snorted in alarm and moved slowly away. It walked a few steps down the muddy shore and then turned back, looking at her reproachfully. But she could see it now. Small head, thick neck, huge lumbering body with a double row of pentagonal plates running along the crest of the back. A dragging tail with spikes in it. Harding blinked. It couldn't be. Confused and dazed, her brain fumbled for the name of this creature, and it came back to her, all the way from childhood. Stegosaurus. It was a goddamn Stegosaurus. In her astonishment, her mind went back to the glaring white hospital room when she had visited Ian Malcolm in his delirium, when he mumbled the names of several dinosaurs. She had always had her suspicions. But even now, confronted by a living stegosaur, her immediate reaction was that it must be some kind of a trick. Sarah squinted at the animal, looking for the seam in the costume, the mechanical joints beneath the skin. But the skin was seamless, and the animal moved in an integrated, organic way. The eyes blinked slowly. Then the Stegosaurus turned away from her, moved to the water's edge, and lapped it with its large, rough tongue. The tongue was dark blue. How could that be? Dark blue from venous blood? Was it cold-blooded? No, this animal moved much too smoothly. It had the assurance and indifference of a warm-blooded creature. Lizards and reptiles always seemed to be paying attention to the temperature of their surroundings. This creature didn't behave that way at all. It stood in the shade and lapped up the cold water, indifferent to it all. She looked down at her shirt, saw the foamy spittle running down from her neck. It had drooled on her. She touched it with her fingers. It was warm. It was warm-blooded, all right. A Stegosaurus. She stared. The Stegosaurus's skin had a pebbled texture, but it was not scaly like a reptile's. It was more like the skin of a rhino, she thought, or of a warthog, except it was entirely hairless, without the bristles of a pig. The Stegosaurus moved slowly. It had a peaceful, rather stupid air. And it probably was stupid, she thought, looking again at the head. The brain case was much smaller than that of a horse, very small for the body weight. She got to her feet and groaned. Her body ached. Every limb and muscle was sore. Her legs trembled. She took a breath. A few yards away, the Stegosaurus paused, glanced at her, taking in her new upright appearance. When she did not move, it became indifferent once again and returned to drinking from the river. "I'll be damned," she said. She looked at her watch. It was 1:30 in the afternoon, the sun still high overhead. She couldn't use the sun to navigate, and the afternoon was very hot. She decided she had better start walking and try and find Malcolm and Thorne. Barefooted, moving stiffly, her muscles aching, she headed into the jungle, away from the river. After walking half an hour, she was very thirsty, but she had trained herself to go without water for long periods in the African savannah. She continued on, indifferent to her own discomfort. As she approached the top of a ridge, she came to a game trail, a wide, muddy track through the jungle. It was easier walking along the trail, and she had been following it for about 15 minutes when she heard an excited yelping from somewhere ahead. It reminded her of dogs, and she proceeded cautiously. Moments later there was a crashing sound in the underbrush, coming from several directions at once, and suddenly a dark green, lizard-like animal about 4 feet high burst through the foliage at terrific speed, shrieked, and leaped over her. She ducked instinctively, and hardly had time to recover before a second animal appeared and raced past her. Within instants, a whole herd of animals was running past her on all sides, yelping in fear, and then the next one brushed against her and knocked her over. She fell in the mud as other animals leaped and crashed around her. A few feet ahead on the trail, she saw a large tree with low-hanging branches. She acted without thinking, jumping to her feet, grabbing the branch, and swinging up. She reached safety just as a new dinosaur, with sharp-clawed feet, rushed through the mud beneath her and chased after the fleeing green creatures. As this animal went away from her, she glimpsed a dark body, 6 feet tall, with reddish stripes like a tiger. Soon after, a second striped animal appeared, then a third. A pack of predators hissing and snarling as they pursued the green dinosaurs. From her years in the field, she found herself automatically counting the animals that rushed past her. By her count, there were 9 striped predators, and that immediately piqued her interest. It made no sense, she thought. As soon as the last of the predators was gone, she dropped down to the ground and hurried to follow them. It occurred to her that it might be foolish to do so, but her curiosity overcame her. She chased the tiger dinosaurs up a hill, but even before she reached the crest, she could tell from the snarls and growls that they had already brought an animal down. At the crest, she looked down on their kill. But it was like no kill she had ever seen in Africa. On the Seronera Plain, a kill site had its own organization, which was quite predictable and, in a way, was almost stately. The biggest predators, lions or hyenas, were closest to the carcass, feeding with their young. Farther out, waiting their turn, were the vultures and marabou storks, and still farther out the jackals and other small scavengers circled warily. After the big predators finished, the smaller animals moved in. Different animals ate different parts of the bodies. The hyenas and vultures ate bones. The jackals nibbled the carcass clean. This was the pattern at any kill, and as a result there was very little squabbling or fighting around the food. But here she saw pandemonium, a feeding frenzy. The fallen animal was thickly covered with striped predators, all furiously ripping the flesh of the carcass, with frequent pauses to snarl and fight with each other. Their fights were openly vicious. One predator bit the adjacent animal, inflicting a deep flank wound. Immediately, several other predators snapped at the same animal, which limped away, hissing and bleeding, badly wounded. Once at the periphery, the wounded animal retaliated by biting the tail of another creature, again causing a serious wound. A young juvenile, about half the size of the others, kept pushing forward, trying to get at a bit of the carcass, but the adults did not make room for it. Instead, they snarled and snapped in fury. The youngster was frequently obliged to hop back nimbly, keeping its distance from the razor-sharp fangs of the grown-ups. Harding saw no infants at all. This was a society of vicious adults. As she watched the big predators, their heads and bodies smeared in blood, she noticed the criss-cross pattern of healed scars on their flanks and necks. These were obviously quick, intelligent animals, yet they fought continually. Was that the way their social organization had evolved? If so, it was a rare event. Animals of many species fought for food, territory, and sex, but these fights most often involved display and ritual aggression. Serious injuries seldom occurred. There were exceptions, of course. When male hippos fought to take over a harem, they often severely wounded other males. But in any case, nothing matched what she saw now. As she watched, the wounded animal at the edge of the kill slunk forward and bit another adult, which snarled and leaped at it, slashing with its long toe claw. In a flash the injured predator was eviscerated, coils of pale intestine slipping out through a wide gash. The animal fell howling to the ground, and immediately 3 adults turned away from the kill and jumped onto its newly fallen body and began to tear the animal's flesh with rapacious intensity. Harding closed her eyes and turned away. This was a different world, and one she did not understand at all. In a daze, she headed back down the hill, moving quietly, carefully away from the kill. Noise. The Ford Explorer glided quietly forward along the jungle path. They were following a game trail on the ridge above the valley, heading down toward the high hide in the valley below. Thorne drove. He said to Malcolm, "You were saying earlier that you knew why the dinosaurs became extinct." "Well, I'm pretty sure I do," Malcolm said. "The basic situation is simple enough." He shifted in his seat. Dinosaurs arose in the Triassic about 228 million years ago. They proliferated throughout the Jurassic and the Cretaceous periods that followed. They were the dominant life form on this planet for about 150 million years, which is a very long time. "Considering we've been here for only 3 million, Eddie said. "Let's not put on airs," Malcolm said. "Some puny apes have been here for 3 million years. We haven't. Recognizable human beings have only been on this planet for 35,000 years, he said. That's how long it's been since our ancestors painted caves in France and Spain, drawing pictures of game to invoke success in the hunt. 35,000 years. In the history of the Earth, that's nothing at all. We've just arrived." "Okay. And of course, even 35,000 years ago, we were already making species extinct. Cavemen killed so much game that animals became extinct on several continents. There used to be lions and tigers in Europe. There used to be giraffes and rhinos in Los Angeles. Hell, 10,000 years ago, the ancestors of Native Americans hunted the woolly mammoth to extinction. This is nothing new, this human tendency." "Ian." "Well, it's a fact, although your modern airheads think it's all so brand new." "Ian, you were talking about dinosaurs." "Right. Dinosaurs. Anyway, during 150 million years on this planet, dinosaurs were so successful that by the Cretaceous there were 21 major groups of them. A few groups, like the Camarasaurs and Fabrosaurs, had died out, but the overwhelming majority of dinosaur groups were still active throughout the Cretaceous. And then, suddenly, about 65 million years ago, every single group became extinct, and only the birds remained. So, the question is, what was that?" "I thought you knew," Thorne said. "No, I mean, what was that sound? Did you hear something?" "No," Thorne said. "Stop the car," Malcolm said. Thorne stopped the car and clicked off the engine. They rolled down the windows and felt the still midday heat. There was almost no breeze. They listened for a while. Thorne shrugged. "I don't hear anything. What did you think you—" "Shh," Malcolm said. He cupped his hand to his ear and put his head out the window, listening intently. After a moment he came back in. "I could have sworn I heard an engine." "An engine? You mean an internal combustion engine?" "Right." He pointed to the east. "It sounded like it was coming from over there." They listened again and heard nothing. Thorne shook his head. "I can't imagine a gas engine here, Ian. There's no gas to run one." The radio clicked. "Dr. Malcolm?" It was Arby in the trailer. "Yes, Arby? Who else is here on the island?" "What do you mean?" "Turn on your monitor." Thorne flicked on the dashboard monitor. They saw a view from one of the security cameras. The view looked down into the narrow, steep East Valley. They saw the slope of a hillside, dark beneath the trees. A tree branch blocked much of the frame, but the view was still silent. There was no sign of activity. "What did you see, Arby?"
"Just watch."
Through the leaves, Thorne saw a flash of khaki, then another. He realized it was a person, half walking, half sliding down the steep jungle slope toward the floor below. Small, compact frame, short, dark hair. "I'll be damned," Malcolm said, smiling. "You know who that is?" "Yes, of course. It's Sarah." "Well, we better go get her." Thorne reached for the radio, pressed the button. "Richard," he said. There was no answer. "Richard, are you reading?" There was no answer. Malcolm sighed. "Great, he's not answering. Probably decided to go for a walk, pursuing his research." "That's what I'm afraid of," Thorne said. "Eddie, unhook the motorcycle and go see what Levine's doing now. Take a Lindstrat with you. We'll go pick up Sarah." Trail. Levine followed the game trail, moving deeper into the darkness of the jungle. The parasaurs were somewhere up ahead, making a lot of noise as they crashed through the ferns and palms on the jungle floor. At least now he understood why they had formed into a single file. There was no other practical way to move through the dense growth of the rainforest. Their vocalizations had never stopped, but Levine noticed they were taking on a different character, more high-pitched, more excited. He hurried forward, pushing past wet palm fronds taller than he was, following the beaten trail. As he listened to the cries of the animals ahead, he also began to notice a distinctive odor, pungent and sweet-sour. He had the feeling the odor was growing stronger. But up ahead, something was happening. There was no doubt about it. The parasaur vocalizations were now clipped, almost barking sounds. He sensed in them an agitated quality. But what could agitate an animal 12 feet high and 30 feet long? His curiosity overwhelmed him. Levine began to run through the jungle, shoving aside palms, leaping over fallen trees. In the foliage ahead he heard a hissing sound, a sort of spattering, and then one of the parasaurs gave a long, low, trumpeting cry. Eddie Carr drove the motorcycle up to the high hide and stopped. Levine was gone. He looked at the ground around the hide and saw many deep animal footprints in the ground. The prints were large, about 2 feet in diameter, and they seemed to be going off into the jungle behind the hide. He scanned the ground and saw fresh boot marks as well. They had an solo tread. He recognized them as Levine's. In some places the boot marks disrupted the edge of the animal footprints, which meant that they had been made afterward. The boot marks also led into the forest. Eddie Carr swore. The last thing he wanted to do was to go into that jungle. The very idea gave him the creeps. But what choice was there? He had to get Levine back. That guy, he thought, was getting to be a real problem. Eddie unshouldered the rifle and set it laterally across the handlebars of the motorcycle. Then he twisted the grips, and silently the bike moved forward into darkness. Heart pounding with excitement, Levine pushed past the last of the big palms. He stopped abruptly. Directly ahead of him, the tail of a parasaur swung back and forth above his head. The animal's hindquarters were turned toward him, and a thick stream of urine gushed from the posterior pubis, spattering on the ground below. Levine jumped back, avoiding the stream. Beyond the nearest animal, he saw a clearing in the jungle, trampled flat by countless animal feet. The parasaurs had located themselves at various positions within this clearing, and they were all urinating together. So they were latrine animals, he thought. That was fascinating and totally unexpected. Many contemporary animals, including rhinos and deer, preferred to relieve themselves at particular spots, and many times the behavior of herds was coordinated. Latrine behavior was generally considered to be a method of marking territory. But whatever the reason, no one had ever suspected that dinosaurs acted in this way. As Levine watched, the parasaurs finished urinating, and each moved a few feet to the side. Then they defecated, again in unison. Each parasaur produced a large mound of straw-colored spoor. This was accompanied by low trumpeting from each animal in the herd, along with an enormous quantity of expelled flatus, redolent of methane. Behind him a voice whispered, "Very nice." He turned and saw Eddie Carr sitting on the motorcycle. He was waving his hand in front of his face. "Dino farts," he said. "Better not light a match around here, you'll blow the place up." "Shh," Levine hissed angrily, shaking his head. He turned back to the parasaurs. This was no time to be interrupted by a vulgar young fool. Several of the animals bent their heads down and began to lick the puddles of urine. No doubt they wanted to recover lost nutrients, he thought, perhaps salt, or perhaps hormones. Or perhaps it was something seasonal, or perhaps... Levine edged forward. They knew so little about these creatures. They didn't even know the most basic facts about their lives, how they ate, how they eliminated, how they slept and bred. A whole world of intricate, interlocking behaviors had evolved in these long-vanished animals. Understanding them now could be the work of a lifetime for dozens of scientists. But that would probably never happen. All he could hope to do was make a few conjectures, a few simple deductions that skimmed the surface of the complexity of their lives. The parasaurs trumpeted and headed deeper into the forest. Levine moved forward to follow them. "Dr. Levine," Eddie said quietly, "get on the bike, now." Levine ignored him, but as the big animals departed, he saw dozens of tiny green dinosaurs leap, chittering, out into the clearing. He realized at once what they were. Procompsognathus triassicus, small scavenger found by Frass in 1913 in Bavaria. Levine stared, fascinated. Of course he knew the animal well, but only from reconstructions, because there were no complete skeletons of Procompsognathus anywhere in the world. Ostrom had done the most complete studies, but he had to work with a skeleton that was badly crushed and fragmentary. The tail, neck, and arms were all missing from the animals Ostrom described. Yet here the Procompsognathids were fully formed and active, hopping around like so many chickens. As he watched, the compies began to eat the fresh dung and drink what was left of the urine. Levine frowned. Was that part of ordinary scavenger behavior? Levine wasn't sure. He edged forward to look at them more closely. "Dr. Levine," Eddie whispered. It was interesting that the compies only ate fresh dung, not the dried remnants that were everywhere in the clearing. Whatever nutrients they were obtaining from the dung, it must only be present in fresh specimens. That suggested a protein or hormone that would degrade over time. Probably he should obtain a fresh sample for analysis. He reached into his shirt pocket and withdrew a plastic baggie. He moved among the compies, which seemed indifferent in his presence. He crouched down by the nearest dung pile and reached slowly forward. "Dr. Levine!" He glanced back, annoyed, and in that moment one of the compies leaped forward and bit his hand. Another jumped onto his shoulder and bit his ear. Levine yelled and stood up. The compies hopped onto the ground and scampered away. "Damn it," he said. Eddie drove up on the motorcycle. "That's enough," he said. "Get on the damn bike. We're getting out of here."